So today I'm going to present Pinging in the Rain, a preliminary measurement study where we see how weather affects residential internet connections. And this is a bit different than many of the other outage studies that are out there. The one that was presented yesterday, for example. We're not focusing on large-scale outages. Instead, we're sort of focusing on the small-scale everyday outages, the sort of routine mini natural disasters that happen every day. And also, we know that providers track this information, how weather affects their networks, but we're looking globally. We're looking across providers. So there are 3 steps that we use to figure out how weather affects the internet. First, we identify residential IPs that are subject to weather. And that means we basically track weather forecasts, and when there's a forecast for a particular area, we find IPs in that area and ping them. The next step is pinging them. We ping them before the weather event, during it, and after, so we can see the host if it went down from up to down due to the weather event. And finally, we analyze this data. These pings are noisy, so we have to figure out somehow, we have to identify if there's a failure in that noisy data. So how do we aim our pings at weather? Well, the US National Weather Service provides this lovely XML feed of weather alerts, and basically, there are a diverse set of alerts talking about thunderstorms, fog, all sorts of different things. And in this example, you see this is a thunderstorm alert for Green Bay, Wisconsin. And there are 2 key fields here. This tells us when to ping, when the alert is effective, and we ping 6 hours before the alert, and when it expires. And also these geocodes, which you see at the bottom. And these are called FIPS codes, which are basically county codes. They identify the counties that are affected. Now, the next thing is, well, how do we identify the IPs, the residential IPs that are in these counties? And to do that, we do a targeted reverse DNS scan of all the residential providers in the US. And the ones that match, that look like they have customer strings, like a number dash a number dash a number, we identify those as being residential customers, use MaxMind's database to find out where they are, and that's how we ping them. Okay, so we have the weather forecast. We know which customers we're going to ping. How do we ping them? So we use regular old ICMP pings to observe failures, but it's not enough just to ping at a fixed interval from one vantage point. We believe in order to confidently identify failures, we have to ping from multiple vantage points. First, we need these multiple vantage points. We use 10 vantage points from Planet Lab that are scattered all around the US. Second, we're sending unsolicited probes to you guys, so we got to be friendly. And we send, thus we send at 11-minute intervals, which one ping every 11 minutes from each vantage point. So far, we haven't had an abuse report, which I'm glad to hear. And the third thing is we have to manage these limited ping resources. We're pinging hundreds of thousands of residential hosts. So we have to manage these resources. We don't have that. Planet Lab has limited bandwidth. So if there's no response from a host within the first hour during a weather alert, we say, okay, throw this out. We'll just ping the other guys. And finally, occasionally pings are going to be lost for whatever transient network issues. So after a ping is lost, we do sort of a retry process immediately after a few times to see if that ping is due to a transient, or that loss was transient, or it's due to something that's much more serious. Okay, so let's see what this data looks like. This is a host that went down during a thunderstorm, and on the y-axis you see those 10 vantage points, and on the x-axis there is time. And basically you see that this host was up, even though there were a few dropped pings for whatever reason, and then it went down in the middle and then back up after the thunderstorm had passed. Okay, so we have this data for tons of hosts. Let's try to get a sense, and also we have this weather data. Let's get a sense of what all this looks like. Well, remember, we only have weather forecasts. We need to know exactly what the weather was at a host while we were pinging it. So how do we do that? Well, awesome. In the US, there are tons of airport weather stations that are scattered all over. And also they're standardized, which is great. And there are a bunch of sensors on them that we could use. In the initial study, we used the precipitation identification sensor, which tells you if it's snow or rain and how dense that is. There's also a lightning detection network, which is not shown here, but it's an array of antennas scattered around the US that they use to pinpoint lightning strikes. Okay, so let's see what the weather data looks like. If you've flown planes before, you're probably familiar with meter records. And basically, about every hour, a measurement is taken from all these sensors. In this example, you see Flagstaff, Arizona, FLG, KFLG. And basically, the weather at this airport goes from clear to light thunderstorms to hazy, clear to hazy, light thunderstorm, heavy thunderstorm. This is the data that we use. We map each ping to this data to say what was the weather while we were pinging this host. Okay, so let's see what this data looks like. During Hurricane Irene, we were probing from those 8 or 10 vantage points. And this is an animation of what we saw. The green dots and red dots are hosts. A green dot indicates up, red indicates down. And the diamonds are airports. When they're gray, the weather is clear. When they're blue, there's rain in that area. And you can see that the storm is now moving up. If you look in this area in particular, the storm is moving up into the Maryland, Virginia area. And as like these blue diamonds are showing up, and as this is happening, hosts are going down. And at the point when this animation stops, which is pretty soon, it turns out that our host that was doing the pinging, which was based in Maryland, lost power, and I didn't realize it wasn't on battery backup, which is very unfortunate. So we had this blank amount of time till I restarted it to see what would happen. Okay, so let's look at some of the preliminary results from this data. We captured 66 days worth of these pings, and we focus our analysis on a few providers that are across different types of links. The real question for us here is there a similar failure rate across providers? That might indicate maybe it's just power failures that's happening, not something like water seeping into coax. But that also wouldn't necessarily tell us that, but we want to look at it sort of across providers. So the simple metric we use is we add up all the failures we've seen, and we divide it by the total time that we've been looking at IPs at that host. Very simple metric. There are issues with it, but it should give us a general idea of what's going on. Okay, so here's a graph for those providers, exactly what the failure rate that we observed for the different weather conditions across these providers. And we see that in clear conditions, you see a failure generally once every 35 days. Don't know what exactly the reason is for that. That's sort of a cross-provider thing, of course, a little bit different for each. But that could be also due to DHCP leases expiring. It's not clear. But we do see that in general, it seems like in the thunderstorms and rain, in general, the bars are higher. So this graph isn't entirely fair. We don't want to say this provider is any worse than any other because there's a higher failure rate. If you're deploying in an area that's really difficult, has tough weather conditions, this graph isn't really useful. So instead, we normalize each provider. So we change the y-axis and normalize the bars. We're looking at the normalized failure rate for each provider. And we see that in general, in rain and thunderstorms, in rain in particular first, the failure rate in rain across providers is 2 times the failure rate in clear conditions. There are, of course, exceptions there, Cox in particular. And after some further investigation of the data that we have for Cox, it seems like there are maintenance windows that seem to be going on where all the hosts are sort of going down around at the same time, no matter what weather it's in. I would, of course, like to talk to you guys to see if that's actually what's happening. And also we have, in thunderstorms, it's about 4 times the failure rate when the conditions are clear. So I have some questions for you. This is preliminary data. First of all, what are you guys doing to measure the routine failures on your network, these routine weather failures? So how are you monitoring them? How are you monitoring them? And also, what failures do you see? I have this hypothesis that water is seeping into wires. Is that really happening? Anyway, so that's all. Questions?
Jay Hennigan with Impulse Advanced Communications in Santa Barbara.
Yep.
Fortunately, Santa Barbara has somewhat nicer weather than this most of the time. We find that water seeping into wires is indeed a problem for us, particularly some of our legacy services. We kind of joke about, oh, it's going to be a rainy day T1 day today. We don't maintain a lot of that plant. We rent the copper plant from Verizon.
Right.
So we don't really have any direct correlation there, and we're not really that heavily into the residential market. What we are seeing with most of these failures is they are power related.
Right.
And so we'll have a number of small, medium business customers within a certain business park or a fairly a moderate part of the city, and I can tell you how long each one of their UPS batteries lasts, because we'll just see them falling down like dominoes, and then when the power is restored, they all come back at the same time. So I would say that from our experience, the majority of the outages, as far as a network outage where we get paged that a customer is down, seem to be more related to the Edison plant than the communications plant.
Okay, gotcha. Thanks. Anyone else?
So next up is Michael Winder.
Okay, good afternoon. I'm Martin Winter. I work for ISC. I want to talk a little bit about what ISC is doing with basically the open source routing initiative to improve Quagga. So the few of you who use Quagga or try to use Quagga, you probably know about all the issues. I mean, there are quality issues in there. There are a lot of problems there where it doesn't work reliable enough. You may see crashes. The ones running exchange points or trying to use as a route server, you're very familiar with the performance issues, especially on BGP. There is no multi-threading, so you basically have BGP, one simple CPU core using, and that's it. You may be missing features. Obviously, if you want to run it as a router, you may need MPLS. You may need SNMP into the routing daemons as well. There may be some other features in there which is missing. So there are a lot of issues basically which stop people today using Quagga. At the same time, if you look in the branches, it's like also very diverse today. You have like different branches. There's the Quagga.net, the kind of official branch. There is a Google branch, which they basically the rewrite of ISIS and also for BGP multipass, which you can find online. Vayata is like as a commercial vendor who built their own branch because they couldn't get it working enough with the open source, the community one. You may even have your own branch, so, and there are tons of other private branches. Chris Hall is doing one with some exchange points using too, a lot of BGP enhancements too. But despite all these issues, it's still actually very widely used, and a lot of vendors are actually looking at it, using Quagga as a reference platform, and they would love to have it in a more stable thing. So just a quick overview. Basically, that's where we hope to help out as open source routing, as a non-profit part of ISC. We hope that we can basically go and improve the Quagga by like helping testing, setting up a better test bed, by like merging some of these branches back together so we have a few less branches there. In the future, maybe we offer support and other things, but that's nothing we need to talk about this year. The key thing is we are not Quagga.net. There are people out there that do an amazing job there. Obviously, they're resource constrained too. And we hope that we help out them and not compete with them. So from the testing, we started basically, we are quite new. The whole project started in August last year. There we went through a lot of testing. We do some compliance testing. So we went through the RFC compliance part. We did some resilience testing where we use protocol fuzzers to see like what happens, where are we missing checks there, like which may be common issues for some of the crashes you see. And we also started writing our own test plans, part of it for doing more combined things which are not covered by either of these things. And if you're interested, In difference to other places I used to work before, we are open source there. Everything is public and documented. It's on our wiki. You can read our test plans. Feel free to give us input. You see things. Maybe you can use some of that thing. Go ahead. So quick status, we mainly tested today the 9920 branch. We found lots of errors, which we are now analyzing it in resilience and also in the RFC compliance. We also tested the Google ISIS code so far, but that's basically the two things which we so far tested. Interesting for the ones of you who are more on the technical side, who part of you have like the job that you have to test routers. Feel free to talk to me. It's kind of an interesting field. There are also a few extra challenges, especially working open source. I mean, there is one classic example. There are no real open source test suites. There are like, normally companies develop their own test plans, some of them like excellent test plans, but they keep it confidential. They don't hand it out. I would love to see if somebody of you is willing to share things. It's like interesting to see what you're testing there and how you test it. The other thing is also many of these tools are commercial tools, which are especially using in the open source community challenging, because I want to be able, when I find an error, to document that thing. How is this things like, can you reproduce that issue so you can verify that patch? And if you have a closed tool, you can't give the whole world that tool out for access for verifying it. So if you have things developed there too, it would be very interesting. Replay routes is kind of a nice thing. I had this idea, especially for BGP. I wanted to replay like a year's worth of like maybe BGP updates and see how it reacts. The fun is there is a really nice community out there. RIPE does an excellent job collecting like BGP updates and tables in MRT format. The problem is all of these seem to be collected with Quagga itself. So if I want to see issues which are like may cause a problem for Quagga, crashing Quagga, they may not be in that recording because the recording device actually had an issue. So if any one of you has a private collection of BGP updates who is not recorded with Quagga, I would love to hear about that. The other thing is also obviously limited resources. I hope that I can automate a lot of these things and have it well documented. So if you're interested to see how we do things, to clone things, maybe you want to use it for testing some completely different open source project or your own commercial routers, go ahead. As I say, our testing information will be well documented all online there. On the development side, as I say, the key thing is currently we're looking at the different branches, because all these about 10 different branches out there that take a lot of the resources on the community. We really hope to reduce that to a fewer branches so we can coordinate the testing, the community there. There are a lot of people, they usually build their own big features in there. They try to submit it back to the official Quagga nets, but unfortunately, if it's like a few hundred lines or 1,000 lines, most of the time the community never had time to review it, so it ended up that it wasn't accepted and people started their own private branch. So that's how it happened. And we really hope that we can bring things back together there. We're also spending right now a lot of time on bug scrub, going through it, analyzing all the different issues, and hope we can find and fix a lot of the bugs and get it much more stable. And the other thing is obviously also looking at different other features, and we are very interested there to see things missing, parts which you basically implemented yourself in a rough part or maybe even in a working version, and you're feeding back to feed stuff back. That's very interesting for us. So my final slide, just basically the key thing, what I'm looking for, hoping here to hear back. If you're basically running Quagga today in your network, or if you tried to run it and you failed with some recent version, I would love to hear what was the main issue. We know the big performance issue on BGP part, but if there were other big issues, maybe you tried it and you ran into major bugs and you wonder why has nobody ever tested that. Please talk to me. I would love to make sure that things like that get tested and end up in a test plan. As also maybe you have your own private branch which I don't know about it yet. And maybe you don't want to continue keeping that all private and you rather have it in an open branch, donating that stuff back to your code out in an open source thing and shared with everyone and tested by much more people and like evolved there. So please talk about it. Tell me about it so we can make sure and address it, and we can talk to you, see how we can integrate that thing too. Maybe just a simple feature you added yourself for your own network monitoring thing, something which you think is really cool. So let me know. At the bottom you see the URLs. Feel free, as I say, it's open source. I try to document about as fast as I can all the things we're doing. Test plans too. Feel free to read it, give us feedbacks. They're like some of the things is a little bit at the beginning, but it should be all there. Or send me an email. Okay, we have a little bit time for some questions if somebody has anything. Yeah.
John Kemp for RoutViews. I'm just curious, because it seems like about a year ago, Dennis Ovsienko started a release engineering branch, and it almost seemed like that was going to be the place that further Quagga development really started to come together. And I wondered if you'd talked to him or you guys had any discussions on whether or not people would head this way or go that way.
Are you talking about the release engineering branch which Dennis did? Okay, yeah, so there is something he tries to do. I think he does quite a good job. The part is like he's obviously time limited too, and the main issue we have a few vendors who approached us like Viata and Google and other things. They have huge changes in there, and they have a hard time to get that back in. I mean, I can understand him. He doesn't want to like get all the changes back in there, especially if he doesn't have time to review it. And that's basically the challenge a bit. Like, as an example, Google, they basically completely rewrote the ISIS, but that's thousands of lines, and nobody seems to have time to review it. So I'm not sure how much he may be willing to, in the future, to go together there and see how we can help each other. It's kind of open there. I mean, I don't see him as competition. I have quite good communication with him at this time. So,
right. Jared Mach, New Star. So we had gone and made a minor, just simple change to one of our Quagga instances to sort of adapt some of the file permission handlings and whatnot of all the update and the MRT files that are output to make them more usable. Is that something we can contribute upstream?
Sure. If you think it's a useful change, please send me an email. I would love to like look at it and see what it does and why and everything.
Okay. Thanks.
Thank you, Martin. Next up. Next up is Chris Grundemann. Are you here? There you are. Excellent. While we wait for Chris to come, please check that your phones and your PCs are on mute or silence so we're not interrupting people here. Thank you.
So this afternoon I'm going to talk to you about CGN logging. It is a horror story, but lucky for you it comes with a happy ending. So first I want to give just a little bit of background on why I'd want to talk about logging of a carrier-grade NAT device. And today you can just go to DHCP logs and figure out what subscriber has what address and respond to abuse reports or law enforcement reports or whatever it might be. Once you put a CGN device in the middle, you have to step through that, right? So the public address is going to show up on the web server log. That has to be tracked back to the CGN log, which then can point you to the private address in the DHCP log, which can get you back to the subscriber. So now you have to maintain these two logs for whatever period you maintain logs for in order to be able to respond to abuse complaints accurately. In that, Cable Labs has been doing testing on CGN for about 2 years now. We've done fairly extensive testing across a number of applications, a number of devices. Logging is one piece of that was somewhat surprising to us. Janesh Doshi is here. He's an intern with Cable Labs who's done most of the testing. So if you want to know more about the other testing we've done and the results we've found, find one of us in the halls and we can definitely have a good conversation. But with logging specifically, there's some highlights here that I wanted to point out. And actually, I guess they're really lowlights. There's some gaps right now in what's being offered. First of all, pretty much every device on the market today only allows syslog for remote logging. So that's kind of a limitation. And then even on top of that, the template for the logs isn't configurable. So you basically get what you get. The syslog facility is configurable, so you can set it to different servers and things like that. That's great. But for most of the devices, you get these set data fields, and you can't change the format or what's included, and so you can't change the size of your log messages, which are fairly large, right? So we've seen log messages from 150 bytes up to over 500 bytes for a single message, and it varies. So here's an example of some DS Lite logs. You can see the first one there is basically enormous compared to the one that comes right after it. NAT 444 is the same way. You can see the first one, then the second one's double the size, the third one is triple the size of the first one. So you're getting these very log size messages, and you're getting a lot of them. So we haven't found a way to nail down exactly how many connections the average subscriber is using on a daily basis, but we think we've got the order of magnitude right, and it's somewhere between 33,000 and 216,000 connections per subscriber per day. So when you multiply that, don't add it, multiply it by 150 to 450 bytes per connection, you come out with somewhere between 5 and 100 megabytes per user per day of log data, which means we're talking about over a petabyte of data per million subscribers per month, right? I mean, it's massive amounts of data. And possibly worse than that, if you look at a CGN device that's maybe supporting 50,000 subscribers, you're talking about over 20 megabits per second of log data just coming off the device, just for logging. So obviously we have a problem here. This is really not a sustainable model. It's just not going to work. You cannot do per connection logging on your CGNs if you have any kind of size in your network. Luckily, there's some options. So today, fairly widely implemented by pretty much every CGN vendor is port block reservations. They may call it different things, but basically, when the subscriber comes to the CGN for a port, instead of getting one port, the CGN reserves a block of ports, maybe 100 ports. And so now you've got this block of ports, and the subscriber can use any of those ports. The state has to be maintained, but there's no additional log messages. So you just have the one log message for the first block allocation, and then they use the ports within that. So that reduces the logging quite a bit. You can also do log compression, which of course lowers the size on the disk, but it doesn't really lower search time. It doesn't lower the amount of data you're sending to the syslog server, things like that. So a proposal that Cablehouse has come up with is deterministic reservation, right? So it's documented in draft Donnelly behave deterministic CGN right now in the IETF. And you basically take the inside address range, the outside address range, and a compression ratio. And what I mean by compression ratio is just how many subscribers you're putting behind a single IP address. So this could be, maybe you want to put 100 subscribers behind one IP address, maybe you need to put 10. Whatever that might be, that's your compression ratio. And so obviously your compression ratio has to be greater than or equal to your inside address, the size of your inside address range divided by the size of your outside address range. The inside address range divided by the compression ratio gives you the number of ports you have per user. And then you set aside the well-known ports, right? So 0 through 1023. And we also set aside a dynamic overflow range. So then each of these ranges within the middle of that, so you take off the top and the bottom of the ports on the IP address, and you've got these ranges in between, and you break those up into ranges that are the size of ports per subscriber that you have available, and pre-reserve those for subscribers. So each subscriber basically, whatever address they get out of the DHCP pool, that correlates with a block of ports that they're able to use on the outside address of the CGN. And in that way, you don't have to do any logging because you can algorithmically determine which user is using which ports at what time based on the configuration of the CGN device and the DHCP server. And then that dynamic overflow range that I talked about is set aside so that if a user goes over this number of ports they have in their range that's assigned to them, they can fall back to a dynamic port allocation based on block port, and that's where you would have to do logging. So of course you still have to maintain state on the CGN device. It doesn't reduce any of that, but the remote logging is completely eliminated, or at least lowered drastically. The obvious limitation here is the compression ratios have to be low. If you want to put 10,000 customers or 1,000 customers behind an IP address, this probably won't work for you. But if you're down closer to 100 subscribers per IP address, this may help quite a bit. So here's kind of what it looks like. You can see we've got your subscribers on the left-hand side there that are getting DHCP addresses, and those addresses, again, correlate to the pools of ports. So port pool 1 goes to address 1, and there could be multiple ways to do this. Algorithmically, you could spread the ports across multiple IPs, you could spread them out within one IP, or you could just have them in single blocks. depending on how you want to give ports to your users. But basically the idea is that you just look at the configuration of the CGN device, the configuration of the DHCP device, and you can algorithmically map the mapping between the range and the address. And then also we would recommend that, if a vendor implements this, they put away or something in the command line to be able to just reverse it automatically, right? Just ask it, hey, who had this port at this time, and it can tell you. And then of course, if the pool gets exhausted, you dump over to the dynamic pool where you do have to do logging. And again, at the top, there's this pool that you could use for static port reservations. You may use that for port control protocol ports. Maybe you have a portal where customers can dial up a static port that they need, whatever it might be. And that's basically it. Unless there's questions. Thanks.
Excellent. Thank you. Oh, yes. One question?
Hi, this is Aditya from Guavas. We talked to a few providers, and they said that their countries have put a restriction that you have to log the destination IP as well as of some of the other parameters. So essentially, they could not use port-based allocation in their scenario. So do you see that happening, which would prevent the use of this compression technique?
Potentially, and that's actually one of the things that prompted this. There was a bill going through the U.S. It was trying to become a U.S. law that was going to mandate something like 18 or 24 months of customer user data. Luckily, that bill has died for the moment, at least. But in response to that, this proposal was born, where we wanted to demonstrate to the U.S. government that you could do this without having the logs. So you don't need those petabytes and petabytes of data. You can have an algorithmic approach. So we hope that having this technology available may reduce the need for those kinds